Hello everyone, these are your 3.6 notes, quadratic inequalities. So quadratic inequalities in one variable is an inequality that can be written in the form ax squared plus bx plus c, or any variation of that. But instead of having an equal sign, you would have some sort of inequality sign, whether it's less than or equal to, greater than or equal to, any of those options will work. So just remind yourself that it can be any of those options. A, B, and C are real numbers, and A cannot equal 0, or else then it wouldn't be quadratic anymore, it would be linear. To solve a quadratic inequality, factor the quadratic expression and consider the sign of the product of the factors for different values of x. One way of doing this is to construct what's known as a sign table or a sign diagram. A sign diagram is a number line which indicates the values for x, which a function is negative, 0, or positive, or undefined. The horizontal axis represents the x-axis. A positive sign, or you can just literally put a positive sign, indicates that the graph is actually above the x-axis, while a negative sign indicates it's below. Values are indicated on the sign diagram at the roots of the function. So we're going to be looking again at roots today to review and kind of help us with our future test. So if we look at these different functions, they're just in different forms. Again, it doesn't matter what the form is, but what we're really looking into are the roots of the equations. So we can see that they're crossing the x-axis in the first one at -2 and 1. So instead of drawing out a full function, what you're going to do is just literally write a number line with those two roots. Then, since the a value is positive, you know that it's going to be concave up. So what I typically do is after I draw my sign diagram, I kind of put in this like fake parabola to remind myself it's concave up. Since it's concave up, I know that on the left-hand side, my graph is rising up. In the middle, it's going below the x-axis, and then it's rising up again on the right-hand side. So I use positives and negatives to indicate that. For the second one, we can see that this parabola does not even touch the x-axis, so we just put a positive sign to indicate that it never actually touched it the whole time and it's positive. For the third one, we can see that it does touch the x-axis, but it only happens once. So we still have to indicate that the root exists there. However, you can still put two negative signs to indicate that it didn't change direction, it didn't go above the x-axis, it just actually came back down. So what we're going to do for each of example 1 is draw a sign diagram to indicate what's happening in each graph. So first things first, you just draw a number line. And our roots are -1 and 3. Then I have to determine what's happening in the graph. So in the left-hand side, I can see that it's below. So that would be negative. Once I hit -1, it goes above. So that would be positive. Then when I hit 3, it is below again. So that would be negative. And I'm just going to put that on my sign diagram instead of putting it on the graph. So we have negatives on the outsides and then a positive in the middle. And it's as simple as that. So let's look at letter B. Letter B has just one root at the value of 1. And we can see on both the right and left-hand sides, they are both above the x-axis. So my sign diagram is going to have a plus and a plus. Then for letter C, you're also going to draw a sign diagram for here. However, there's no roots to indicate. So we don't want to put any roots down, and instead we're just going to describe what's happening using a plus sign since it's above the x-axis. All right, let's look at example 2. sometimes we're not given the graph, and instead we need to do a sign diagram instead for just a function. So what you want to do is essentially set these all equal to 0. When you set it equal to 0, then you can go ahead and figure out the roots. And you are more than welcome to figure these out using whatever method you want, whether that be by hand or by polysmelt or by graphing. But for a lot of these, it's as simple as using some basic algebra skills, such as in letter A, if I set it equal to 0, add 9 to both sides, I get x squared equals 9, take the square root, so x equals plus and minus 3. So those would be my roots. So I draw out my number line, and I indicate -3 and +3. Now I very well could graph this. However, I don't need to, because I know that the value in front of my x squared is equal to 1. So that is bigger than 0, so I know it is concave up. And again, that just means pointing up. So since I know it's pointing up, I can imagine a parabola pointing in the upward direction. I don't have to graph it. It's not going to look perfect, and that's okay. Because again, it's just a sketch to get my mind thinking about what's happening in the graph. And as I can see, on the left-hand side, it is positive, and same thing on the right-hand side. But in the middle, it is negative. For letter B, I'm going to do the same thing. Set it equal to 0. That -3 out front, I could easily divide both sides. And I get x plus 4 squared equals, well, 0 divided by -3 is still 0. So then I have x plus 4 squared, take the square root. You get x plus 4 equals, well, plus and minus 0 is still 0, so just 0. So x equals -4. So that means I only have one answer for this sign diagram. And I'm going to go ahead and draw that out. Put just -4 down. Now here's where I need that knowledge of concave up or down. So I have A being equal to -3, which is less than 0. So this is concave down. Since it's concave down, I know that if I were to draw a parabola, it would come up, hit that 4, come right back down. So that means that both sides are going to be below the x-axis, which means my sign diagram is negative and negative. Letter C, again, set it equal to 0. This one's already factored for me, which is really nice, because then the first value, or the first factor, is x equals 0. The second one, again, you're setting it equal to 0, so you would add 3, so it would just be x equals +3. Now I can go right into my sign diagram. So sometimes these are actually a lot faster than if you were to put it into your GDC and graph it from there. That's why we kind of work through these. So 0, 3, and then again, there's no number in front, but we know that means that A equals 1, which is greater than 0, so it has to be concave up. So I just imagine a parabola going up. So on the right and the left-hand sides, they are positive. In the middle, it is negative. Letter D, we have x squared minus 3x plus 2. If you remember back to your factoring days, you could remember that this is the add multiply, and it works out very nicely. It's x minus 2x minus 1. So that, again, having some basic factoring skills might save you some time on the test because you don't have to put it into polysmelt. So then you get x equals 2, x equals 1. Put those on your number line. There is no value in front, so it's A equals 1, concave up. Imagine your parabola going up. So again, this is plus on the ends, minus in the middle. Letter E is also going to be an add multiply. So two numbers that multiply to 25 that add to 10 are 5 and 5. Since it's the same number, I don't have to write it more than once, so I can just say x equals -5. But again, that means on my number line, I'm only going to have one root displayed, which is -5. A is equal to 1, concave up. Now, again, I'm not going to go through it because there is only one root, so I'm going to have my parabola touch it and then go right back up. But again, I still need to display that root, but my signs are going to be the same on both sides. They're both positive. One more of these, set it equal to 0. For this one, since there is a value out front, polysmelt would probably be the better option unless you are able to guess and check or just really kind of figure out those two factors. But I recommend for any time A is not equal to 1. In this case, it's equal to -3. So you would just use polysmelt. And you're going to use the polyroot finder. It has a degree of 2. And so when you use polysmelt in your GDC, you should get x equals 1 and x equals -4/3. Even though it's a fraction, I can easily put that on my number line because I know -4/3 is less than 1. So it just comes first. Now A is -3, which is less than 0. So this one is concave down. Since it's concave down, I'm going to start low, go through the -4/3, come up, go through the 1, and then it's back down again. So this switches directions. So on the outsides, I'm going to be negative because we're below. In the middle, it's a plus. So to solve quadratic inequalities, what you want to do is take a couple of steps and use this idea of the sign diagram to kind of help you figure out the answers. So first, rearrange the inequality so that the right-hand side is 0 and the left-hand side is the quadratic. Solve the corresponding quadratic equation, whether that is with polysmelt or with some factoring skills or whatever you can think of. To solve the problem. Then you're going to go ahead and just put down the roots and use the sign table to write the solution. So similar to what we did above, however, these were all equal to 0. Technically, what we're seeing in example 3 is not equal to 0. You're going to treat it as if it were equal to 0, but that means we're just going to have to add on an extra step to figure out the final answer. So for this first inequality, I'm going to imagine that it equals 0. A couple of different ways to solve this one is that you can use polysmelt too. You also could realize that this has a factor of 2 in each of them, and you can divide that out. It's totally up to you. Whatever you see it first, I would do that. Since there's a number in front, it might be your instinct to go straight to your GDC and use polysmelt too. And when you do that, you get two answers, x equals -4 and x equals -7. Then you go ahead and write down your sign diagram. -7, -4, make sure it's in the correct order. Since our A value is 2, it's concave up. So again, I'm just going to imagine that parabola so I can write my sign diagram. Then I go ahead and put in the appropriate sign, so plus on the outsides and minus on the insides. So you're probably thinking this is the exact same as what we've been doing, which is correct. However, now you have to satisfy what it was asking. Where is it greater than 0? So in this case, you want to find where is it positive. There we go. So where is it positive? Well, it's positive anywhere less than -7, but then also greater than -4. So that's really all you have to write as your answer. And again, that comes from this idea where is it positive? These two regions. Since I have a number line and it's starting at -7 and going everywhere to the left, I would say x is less than -7. But then on the other side, on the right-hand side, we see that it's going greater than -4. So x is greater than -4, and that is your final answer. All right, so let's try another one of these. So we have the quadratic inequality of x squared plus 3x is greater than or equal to -2. But again, I want this to act like as if it said equals -2 at first, and then we'll go back to the fact that it's an inequality. For this one, I'm just going to add 2 to the other side. So it's x squared plus 3x plus 2 equals 0, because you always want it to equal 0. For me, I recognize that this is an add multiply. I don't need polysmelt, but if you need it, by all means, use it. Your two factors are x plus 2, x plus 1. So your final roots would be -2 and -1. And you go ahead and put those on your number line. And again, make sure they're in the right numerical order, or else it won't be correct. So -2. -1. This one again is concave up as well. And then go ahead and add your symbols. So I put plus signs on the outsides and then a minus on the inside. And it's asking for when is it greater than. So greater than, again, is anything positive. So again, I'm going to use these plus signs. In my answer then, the x is less than or equal to -2, and then x is greater than or equal to -1. So if you do run into the circumstance where instead it looks like a less than sign, so if this problem instead asked where x squared plus 3x is less than or equal to -2, obviously I would take the same steps and I would still end up with the same sign diagram. But instead, I would no longer want where it's positive, and I would want where is it negative. So that would change what my answer looks like. Because in this case, the negative is in between the -2 and -1. So that would influence how I write my answer. And instead, I'd write -2 is less than or equal to x is less than or equal to -1. And that would be my answer. For example, it says find the values of k, which is the function y equals kx squared plus k plus 3x minus 1. Cuts the axis twice, touches the x-axis, or misses the x-axis. So if you recall, this idea we spoke about before, in a previous section, which was about like the quadratic formula and all of that. And we talked about number of roots. So really when it's saying cuts the x-axis twice, you're looking for where does it have 2 roots. Touches the x-axis, that would be 1 root. And then misses the x-axis, that would be no roots. No real roots rather, but no roots for our purpose. So in order to figure those out, we had to first figure out what the discriminant was. And the formula for the discriminant, if you can recall, is delta equals b squared minus 4ac. That's what's under the radical in the quadratic formula. So for this problem, I'm going to need to use the discriminant in order to then figure out, using a sign diagram, the proper information. So let's go ahead and start with the discriminant. Now in this case, a is equal to k, b is equal to k plus 3, and c is equal to -1. Even though there's variables, I'm going to need to use them to try to figure out this problem. So discriminant equals b squared, so k plus 3 squared, minus 4 times a in this case is k, times c, which is -1. I'm going to go ahead and simplify. Now k plus 3 squared, be careful and do not distribute that squared. That is not how that works. You're going to have to go off to the side maybe and do a little bit of foiling work. So k plus 3, you distribute k squared plus 3k plus 3k plus 9. Which is k squared plus 6k plus 9. So let's go ahead and do that. So delta equals k squared plus 6k plus 9. And then simplify the other side. The double negative becomes a positive, so plus 4k. What's nice about this is that there are 2 k's. So I'm going to go ahead and put them together. 6 plus 4 is 10, so delta equals k squared plus 10k plus 9. Now, this should kind of look familiar. It's a quadratic. So you have options. You can either use oh my gosh, polysmelt, or you can recognize that this is a very simple add multiply. Multiply, add. Factors of 9 that add to 10 are 9 and 1. So k plus 9, k plus 1, 10 equal to 0. So your two values are -9 and -1. So great, we found what k is, but we need to know how do we have 2 roots, 1 root, or no roots? Well, those are the values of k that we just found that are possible, right? So all you need to do is put a number line with k on it. So -9, -1. And if we go back to the discriminant, the a value right in here was 1. So we know this is concave up as well. Since it's concave up, it is a plus on the outsides and a minus on the inside. Now, to summarize, we need to figure out letter A. When would it cut the axis twice? Well, that's when the discriminant is greater than 0. That's a fact we learned last time. Well, if that's the case, if it's greater than 0, then I can use my sign diagram and just look at all of the positive values. So in this case, the 2 regions here. So if it's greater than 0, so we have k is going to be less than -9, or k is greater than -1. For letter B, where does it actually touch the x-axis? Well, from our discriminant information from before, we said, well, That's when the discriminant is equal to 0. Well, when it's equal is when it's actually on those roots. So when k is equal to -9 and k is equal to -1. For letter C. When is it missing? When there's no roots. That's when your discriminant is less than 0. When is it less than 0? Well, that's when it's a negative value. Anytime it's negative is only in the middle. So from -9 is less than k is less than -1. One last example. It says let f of x be equal to x squared plus 3x and g of x be equal to 10x minus 4. Solve the inequality for when f of x is less than g of x. Well, anytime that this happens, when you have two equations and you want to see when one is less than the other, you're just looking at where is it underneath. In order to know when it's underneath, you do need your GDC, but you don't need polysmelt or anything like that. You actually need to graph it. So you're going to go to your GDC, and you're going to go ahead and put it into y equals. Your y1 is going to be your f of x, and your y2 is going to be your g of x. So then hopefully you can graph it in there, and you're going to see an image of the graph. So you should have a parabola. And then you should also have a straight linear line. Now this is a sketch, so it's definitely not perfect, but it's going to cut twice. It's just a sketch though. Now if you use second, trace, intersect, you're going to find the intersection points. Now be careful. When you want to find the intersection points, you want to move your arrow keys so that you're close to the intersection point. You don't have to be directly on top of it. Sometimes the calculator won't even go directly on top of it. Just close enough and hit enter until it gives you the coordinate point. So the left coordinate point is at 0.628, comma 2.28 with 3 sig fig rounding. The second one is at 6.37, comma 59.7. Now we're not just going to write down those 2 points. We're going to actually tell which values for x were underneath. So we'll need the x values for this problem here and here. So where is it underneath? We need 0.628 is less than x is less than 6.37. And you can even see, it's not just because they intersect at that point. You can see where f of x is the quadratic. The whole time that quadratic is above the linear line, but once it hits those points, you can see that it goes underneath it right here before it crosses in again and goes above it. So that's why we're looking for that region of the intersections.